Machine. A machine is any device that helps us to do great work with little effort. Examples of machine are the inclined plane, the pulley system, also called the block and tackle system, the hydraulic press, and others. The terms used in describing machines are mechanical advantage, MA in short, velocity ratio, VR, and efficiency. Mechanical advantage is the ratio of the load to the effort. In formula terms, mechanical advantage is equal to the load divided by the effort. It has no unit. Velocity ratio is the ratio of the effort distance to the load distance. In formula terms, velocity ratio is equal to distance of effort divided by the distance of the load. The efficiency of a machine is the ratio of the work output to the work input, expressed as a percentage. Efficiency in formula terms is equal to work output divided by work input times 100%. Efficiency can also be determined using mechanical advantage divided by velocity ratio times 100%. Part of the effort applied to a machine is wasted to overcome friction between the moving parts of the machine. Thus, no machine is 100% efficient. For a pulley system, the velocity ratio is equal to the number of pulleys. For an inclined plane, the velocity ratio is equal to 1 divided by the sine of the angle of inclination. For a hydraulic press, the mechanical advantage is equal to the area of large piston divided by the area of small piston. That gives us pi r squared divided by pi small letter r squared. The pi will cancel out, we are left with r squared divided by small letter r squared, where the capital letter is the radius of the large piston and small letter is the radius of the small piston, also called the plunger. For wheel and axle, another machine, the velocity ratio is equal to radius of the wheel divided by the radius of the axle. So velocity ratio is capital letter R for the wheel, small letter r for the axle. For gear system, velocity ratio is equal to number of teeth on the driven wheel divided by the number of teeth on the driving wheel. Also, the speed of rotation of the larger wheel divided by the speed of rotation of the small wheel is equal to the number of teeth on the smaller wheel divided by the teeth on the larger wheel. For screw jack, velocity ratio is equal to 2 pi r over p. If the handle, otherwise called Tommy bar, of the screw jack is of length L, then velocity ratio is calculated using 2 pi L over P, where P is the pitch of the screw jack. That's the distance between successive threads. Example 1. A hydraulic press has a large circular piston of radius 0.8 meter and a circular plunger of radius 0.2 meters. A force of 500 Newton is exerted by the plunger. Find the force exerted on the large piston. The options are A, 8,000 Newton, B, 4,000 Newton, C, 2,000 Newton, and D, 1,000 Newton. The radius of the large piston, R is 0.8 meters. Therefore, the area of this piston is pi r squared. This will give us pi times 0.8 squared, 0.64 pi meter squared. That's the area of the large piston. Then radius of plunger or the small piston is 0.2 meters. Therefore, the area of the plunger is A1, which is also pi r squared. That area is equal to pi times 0.2 squared. And this will give us 0.04 pi squared. Pi meter squared. That's the area of the plunger. This hydraulic press makes use of Pascal's principle. Pressure is uniformly transmitted in it. In hydraulic press, pressure is uniformly transmitted through the fluid. Therefore, pressure at plunger is equal to the pressure at large piston. And that pressure is force over the area of this plunger is equal to the force at the large piston divided by the area of the large piston. Now we are told that the force at the plunger is 500. This means that 500 divided by the area of the small piston, 0.04 pi, is equal to the force at the large piston divided by the area of the large piston, 0.64 pi. Pi will cancel out from both sides of the equation. This pi, we cancel this, of which F2 will now be 500 times 0.64 divided by 0.04, which gives us 8,000 Newton. Option A is correct. Example 2. Which of the following levers has the greatest mechanical advantage? A, B, C and D. The solution to the problem is as follows. First, we must remember that the mechanical advantage of that machine is the ratio of the load to the effort. To get this ratio, we apply the principle of moment. Applying principle of moment, because the body is balanced or is in equilibrium on the fulcrum. Applying the principles of moment for A, we'll end up getting the clockwise moment about the fulcrum is E times 1. This is equal to the anti-clockwise moment L times 3. So E will give us 3L. Therefore, L over E, which is our mechanical advantage, will give us 1 over 3. If we use the same method for option B, we get mechanical advantage is equal to 1. Option C, mechanical advantage is equal to 3. And option D will give us no mechanical advantage, MA 0. Thus, from the above result, option C is correct. Example 3. A 20-tooth gear wheel drives a 60-tooth one. If the angular speed of the smaller wheel is 120 revolutions per second, the angular speed of the larger wheel is dash. A, 30 revolutions per second. B, 40 revolutions per second. C, 360 revolutions per second. And D, 2,400 revolutions per second. The speed of the larger wheel, divided by speed of smaller wheel is equal to the teeth in small wheel, divided by the teeth in large wheel. So we are told that the teeth in the small wheel is 20, that in the large wheel is 60. Then the next thing we are given is the number of revolutions of the small wheel. So we are looking for the speed of the large wheel. Let's use V for it. The speed of the large wheel, V, divided by that of the small wheel, that is 120, is equal to the number of teeth in the small wheel, that's 20, divided by the number of teeth in the large wheel, and that is 60. This will cancel this. By cross multiply, 6V is equal to 120 times 2. 6V is 240. V is equal to 240 over 6. That is 40 revolutions per second. Option B is correct. Example 4. A wheel and axle have radii 80 centimeters and 10 centimeters respectively. If the efficiency of the machine is 0.85, an applied force of 1,200 Newton to the wheel will raise a load of dash. The options are A, 8.0 Newton, B, 68.0 Newton, C, 8,116 Newton, D, 9,600.0 Newton. The solution to the problem is as follows. Solution. In the question, we are given the radius of the wheel as 80 cm, the radius of the axle as 10 cm, the efficiency of the machine, efficiency as 0.85, the effort applied as 1,200 Newton. Then we are asked to find the load. With these informations, we can get, first of all, the velocity ratio of the machine. Velocity ratio is equal to the radius of the wheel divided by the radius of the axle. The velocity ratio will now give us 80 over 10, that is 8. But we know that there is a relationship between velocity ratio and efficiency. Efficiency is mechanical advantage divided by velocity ratio times 100%. Or we can neglect the 100% and use it as the ratio of the mechanical advantage to the velocity ratio. In that case, we have this as 0.85 mechanical advantage MA divided by velocity ratio 8. That means mechanical advantage is equal to 0.85 times 8. If we effect this multiplication, we are going to get the product of these two will give us 6.8. MA is load over effort. 6.8 will give us the load divided by the effort, 1,200. If we do that, we'll end up getting a load of 8160 Newton. With this result, we find that option C is correct. Option C is correct. Example 5. The efficiency of the pulley system above is 80%. Find the effort E required to lift a load of 1,200 Newton. Option A, 275 Newton. B, 325 Newton. C, 375 Newton. And D, 573 Newton. The solution to the problem is as follows. First, from the diagram, we observe that there are 4 pulleys that make up the pulley system. So the velocity ratio is 4. Velocity ratio is equal to number of pulleys in the system. That means velocity ratio is equal to 4. Now the relationship between velocity ratio and efficiency is equal to mechanical advantage divided by velocity ratio times 100%. The efficiency is 80. Mechanical advantage divided by velocity ratio 4 times 100. If we cross multiply, we have 320 will give us 100 times MA, the mechanical advantage. Therefore, mechanical advantage is 320 divided by 100, which is 3.2. Having obtained the mechanical advantage, we can now look for the effort that is required to raise the load. But mechanical advantage is equal to the load divided by the effort. That's the relationship. Then we fix the value for MA as 3.2. Our load 1,200 divided by the effort. In which case the effort becomes 1,200 divided by 3.2. Then the answer comes out 375 Newton. With that answer, option C is correct.